Hello, welcome to Postgres FM episode number 51. And today I'm alone and first time I do it online. I did many things online on Postgres TV. If you follow just Postgres FM podcast, I encourage you checking out YouTube channel Postgres TV as well. Since we publish their podcast episodes regularly, like weekly, and this actually week number 51. It's insane. Next week we will have anniversary. But also we have other sessions. Sometimes we develop something or we invite some guests and so on. But 51 is insane. It feels insane to have each week one episode, and this is great pace. But unfortunately, my co-host Michael is right now on vacations, and it's very hard for me to choose topic, to coordinate everything. For me, it's easier to do it online because I don't need to redo it and so on. But I apologize in advance for some sounds because usually Michael edits it very well. I don't know how it will sound on podcast, but I will do my best. So choosing topic today was hard, as I said, but I went to Hacker News. I'm using usually Algolia search. I will provide the link below. So I'm using Algolia search and I checked just Postgres or PostgreSQL. Unfortunately, this search considers these words not synonyms. And this week was actually hot in terms of Postgres topics on Hacker News. Many topics made it on the front page, but the most popular one was about threads versus processes. Maybe you know, Heikki, after PGCon, started this discussion in PGSQL hackers mailing list, and this topic became very popular. More than 100 emails in the mailing list itself, and on Hacker News, more than 300, I think 400 maybe, comments. Of course, levels of discussion, deepness, or how to say, the depth of discussions are very different. But anyway, interesting to hear a lot of opinions, but I'm not going to discuss it today, maybe another time. And next, number 2 topic was about upgrades, major upgrades for Postgres using logical replication, involving logical replication to achieve zero or near to zero downtime. This topic is very interesting, and I have a lot of things to say and to share, but maybe later, because there is some ongoing work which is not done yet. Maybe later this year we will share something which will be very interesting. So I chose the third topic. Third topic was related to blog post on Cybertech blog by Ans Asma, and it was about UUID. It's quite well-known problem with traditional UUID, and it's related to performance. But this post was, as usual in Cybertech blog, it was quite concrete in terms of practical examples and numbers and so on. So it's worth discussing. But let me start from some history and from some distance. When I created co-founded my first social network and chose Postgres for the first time, I started it on using MySQL, but it took me just 1 week to realize that I'm not going to stay on MySQL because it was terrible time, like when MySQL was version 3 and so on, and not following what we learned at the university. So I quickly chose Postgres and converted very quickly. And we had it was 2005 or so, very long ago. And we decided that we need to hide real numbers from our competitors. And we wanted to, like when you decide to use surrogate key, you probably see, you probably let your users see current number. For example, you assign it sequentially using, back that time we didn't have generators, we had only serial or big serial data types. sequences, right? And any user, when user is registered, is assigned, we have number assigned, and user can guess how many other users already registered. And if this is your competitor, they probably will start checking you every week, and they will see the growth, like rates of your growth, and not only about users, but also some blog posts, comments, everything. And we decided that we want to hide it. And interesting trick was chosen. It was not my idea, but I implemented it quickly using simple defaults and sequences. So what we did, we wanted some random numbers, but like not real random numbers. So if you take two mutually prime numbers and just multiply sequence value by one of them, and then use modulo operation with another number, you will have looking like kind of random numbers, but it will not be really random numbers, and it will be extremely hard, even if probably not possible, to understand, not knowing these two mutually prime numbers, to understand what is happening. So it will look like some random numbers. Of course, one of these two mutually prime numbers should be very large, very big number. So yeah, so you have like a ring or circle, and you're walking on this circle. So what we did, it was great. It was working great. We used this approach in for all our surrogate primary keys, and that's it. So it was a single primary. We dealt with various scalability issues using Sloany, then Longest, and so on. But in the second social network I co-founded a few years ago, later, we used the same approach, and then we ended up having a real nasty problem. For the first time, it was 2008, I remember it, and we saw the problem when you reach 2.1 billion records. If you use integer 4 primary key, you in some point, when your table is growing very fast, 2.1 billion rows, I mean, not rows, but value 2.1 billion, you cannot insert. Postgres cannot insert anymore, and you have very big problem to solve. To solve it synchronously, you need to have some downtime, many hours of downtime, unfortunately. So since then, I learned you never should use integer 4 primary keys. But what's interesting here, we used basically some kind of random distribution for numbers, and at that time we didn't realize that it's not good in terms of performance. Why it's not good in terms of performance? Because if you usually in social network, social media, most of the time you select users, ask you to select from your database most recent data. For example, provide the last 25 comments or 100 comments for this post, or show most like fresh interesting posts, and so on. And if you use kind of random numbers, or looking like random but not real random numbers, you end up using different pages for each insert in terms of heap, but not only in terms of heap, but also for indexes, because if you use index, probably you use by default it's B3, you end up inserting in different subtrees in B3. So sometimes it's good, but not always. If you have just single node and and your usage pattern is like fresh data is needed more often than old data, in this case, it's not optimal. And we didn't realize it at that time. And then we also saw our competitors don't care anymore about like hiding some numbers and so on. And at some point, I decided also not in my third social network. And since then, I don't care about this like masking real numbers. And I used integer 8 primary keys, and all good, right? But now we live in the world where we use many nodes, and for example, just yesterday I needed to compare behavior of two major Postgres versions, and I needed to dump some samples and plans and so on, and then I needed to analyze plans behavior, explain, analyze buffers on two nodes, and then to compare. And obviously, if I used just regular integer 8 and sequentially assigned, I would have collisions when merging data from two nodes, because, for example, ID 1 and is used on both servers, so we cannot merge this data, and it's like it's solvable, but it's not interesting. So I just used UUID. You install extension, and you start using UUID, and you know collisions are extremely rare, right? So it's all good. But the regular approach, when you so-called traditional UUID, so-called version 4, it behaves like randomly distributed. In this case, if you collisions are very unlikely, it's good to use it as a global value. But since it's randomly distributed, it's going to have not good the state of B3, because when you need again, like you need to check your latest results, you will use a lot of buffers. And this particular post in Cybertech blog discusses this problem, but it goes into interesting direction, which probably was not explored by others before. It discusses the performance of aggregates of count and index-only scans. So with index-only scans, we utilize visibility maps. And of course, in this post, the author performed a vacuum analysis, and so visibility map was fresh, no heap fetches involved, only work with index. So select count, blah, 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 and you check some fresh count of fresh records. And the author compared 3 cases: integer 8, UUID version 4, traditional UUID most people use. If in Postgres, this is what we will use if you decide to use UUID, provided by Postgres itself, by extension, basically. And third option was new kind of UUID, so-called version 7, which is not standard yet, but there is a work in progress standard reviewed right now. And this UUID version 7, it has interesting property. Collisions are also extremely unlikely, but values are generated in kind of sequential like order. So if we order values generated, so basically timestamp is involved under the hood, and if you generate values, you can order by them, and it will have correlation with time. So it keeps this good property to be like, you can use it globally. You can have many primary servers using this, generating this value. Collisions almost like in your life will never happen, but you can order by this value, and it will be the same if you would order by created at column or any column. So similar to regular surrogate integer 8 primary keys. And interesting result was that if you create indexes, of course, bit indexes for all 3 options, and then you first of all, if you check, like first thing interesting was, like I didn't pay attention to it, but it's interesting. Insert time itself already where version 4 traditional UID is losing. It's interesting. It's not losing too much, but it's already losing in terms of insert time. And if you check select count, this is the most interesting part. So timing for version 4 was much worse, but the state was warmed, caches were warmed, so everything was buffer hit. And then the author checks, explain plans to understand why it's slower, why version 4 is slower. As for integer 8 and UUID version 7, quite close. Why so? And there I expected to see it, and I saw it. I saw buffers option used in explain, analyze, plan analysis. We discussed it many times, and I will repeat it many more times. Buffers should be always used when we analyze plans. It should be default, but unfortunately, there were 2 attempts to make it default during the last few years. But unfortunately, both attempts failed, and both hackers decided not to continue. I think everyone agrees it should be default, but somehow it's related to tests Postgres, automated tests Postgres has, and so on. It's hard to implement. But I think if someone wants like this goal to achieve it, it's a great goal to make buffers option default in explain analyze. So when we check buffers, surprise, we see that for integer 4, for integer 8 and UUID version 7, it's almost the same in terms of buffers. This explains similar timing. But for UUID version 4, it's almost 2 orders of magnitude more buffer hits. And then author explains why it's related to visibility maps, and the need for Postgres to check many more pages, many more buffers, because we don't have data locality anymore inside visibility maps as well, and we keep checking many buffers. So this is super interesting, and it means not only for fetching fresh data, sequential generation of surrogate keys, either integers or complex values like UUID is better, but also for aggregates and counting. Postgres has slow count. It's always a problem. Like many people complain. It was improved with improvement of index-only scans. If you have auto-vacuum tuned, index-only scans perform quite well, and counting is faster. But still, this is interesting example. So the bad recipe. Forget about auto-vacuum tuning and use UUID version 4. And you will end up having very slow count. So, but good advice is don't use version 4 UUID, use version 7, which is not like official yet, but you can write simple function to that. It's not a deal. You can find many examples in the internet, or you can even generate it on application side. And then also keep your visibility maps up to date. For that, you need to tune auto-vacuum, because auto-vacuum updates visibility maps. Visibility map remembers which page has all visible tuples. So in page, we have many tuples, and all visible page means that we don't have transactions which would need some tuple, which probably is dead, right? So all tuples are visible to all transactions. So it means like if you make some recent delete or update, you produce some dead tuple, then auto-vacuum needs to clean it, but also in visibility map, the all visible flag will be set to false, meaning that in this page, we probably have some tuples which are visible to some transactions, not visible to some other transactions. But if you keep auto-vacuum settings quite aggressive, auto-vacuum is processing tables often. In this case, you will see a few heap fetches in the plan for index-only scan, and count will be faster. But also you need the sequential ID allocation. And so UUID version 7 is looking very good. Funny thing that a few months ago, on Postgres TV, we had a session with Andrei Borodin and Kirk Wallach, and it was Kirk's idea to let's work on implementation of first it was called UUID, but then we learned that there is standard proposal which describes UUID version 7. So Andrei implemented it and sent to hackers list. You can find it on Postgres TV YouTube channel, and we had good feedback that it's indeed a feature which should be in Postgres. But Peter Eisentraut noted that the standard is not finalized, it's not approved yet. And before approval, it's not good to implement it. We should wait until approval. And then one of the authors of the new version of standard popped up in the hackers mailing list, responding that it's great that you do it and update it with some details. So it was good work. Anyway, I've checked the state of the standard, and on June 10, it changed. This proposal changed its state, and now it's waiting for like new review. And it looks like probably later this year, this standard update, standard change, RFC, I don't remember the number, can be approved. And if it's approved, I think it will be not a big deal to finalize the patch. And in this case, it will probably make it way to Postgres 17. If not, okay, Postgres 18. But it's not a huge patch, right? So once the standard is approved, I hope Postgres will have it. That's probably it. Again, it was hard for me to be alone. I hope next week I won't be alone. If I will, it will be anniversary. It's interesting. We should do something special. If you have some questions, probably we should have some session of answer Q&A, like ask me anything session. So send me anything to Twitter, to YouTube, anywhere, and we will probably work on those questions. And in 2 weeks, Michael will return, and it will be normal podcast. Sorry if I was not like I was doing a lot of it's because no editing this time. Okay, thank you so much. Please share this episode in your social networks and working groups and so on, and let me know what you want next week. Bye.